This is Enterprise Concerns track. The talk is called Inside Apple's MDM Black Box. Please give a warm welcome to David Schutz.
Hi, thank you. As he said, this is Inside Apple's MDM Black Box. I'm David Schutz. I'm a consultant with a company called Intrepidus Group, and here we go. First of all, I wanted to remind everybody we got these great feedback surveys, so be sure you fill that out after the talk so you can help me know what I did well, what I did not. Who am I? My background is, I forgot I've got 2 mics on now. My background is computer science. Though I haven't really used a whole lot of my computer science degree, I kind of got sucked into the world of system administration and help desk just based on the experience I had in school. And about the mid-90s, I got kind of pulled into some information security roles, and I've been there ever since. I really like building tools and solving puzzles, which is kind of pretty much what I did for this talk. I solved a puzzle, and I built a tool. So why am I here? Basically, in a nutshell, we have some enterprise customers out there who use mobile device management, and they'll ask us questions like, how secure is it? And being as how it's our job to help them analyze risks and build a secure network, we kind of like to be able to answer questions like that. But to answer it well, you really have to understand how whatever it is they're asking you about works. It's not enough just to look at a spec sheet or a glossy or something like that, or even to play with a device for a while and just run it through its functional paces. It's not enough to do that to really understand how secure something is. Unfortunately, the protocol wasn't published. So Apple has released the spec for MDM, obviously, to commercial development companies who have built products based on it. But as far as we've been able to find, you can't find it online, so it was difficult for us to really understand. So we reverse engineered it, and we thought we'd share. So why are you here? Hopefully you're here because you want to learn the same things we wanted to learn. You want to learn how it works and how secure it is. Real briefly, we will do a quick review of how the configuration settings on iOS work, especially how the differences between settings you use as a user on the device directly versus settings that are imposed through profiles. And I'll point out some of the differences that actually between those 2 methods. And then we'll dig into the MDM protocol itself. We'll talk about how devices enroll in the system, what happens when enrollment occurs, how the commands are formatted, how the commands and responses go back and forth, et cetera. In the end, you'll actually have enough knowledge to write your own very, very basic server, which is what I did. So you can also use the one that I wrote. We'll also talk about some bugs and weaknesses, some good things, some bad things. And at the end, I hope to talk about a new twist on an old attack. Real quick, I have access to the development programs at Apple, but I haven't used them. There's nothing in this talk that was based on either the Lion NDA, which is now gone because Lion's been officially released, or iOS 5. I haven't even seen iOS 5 running in person, which is quite sad. But everything that's on here uses iOS 4. I'm not sure if there's any changes for 5 or not. So we'll find out in a month or 2, I guess. So let's start with, again, the basic controls. What the users can do on a device directly as far as configuring an iOS device, an iPhone, an iPod Touch, or an iPad. Very simple stuff. You can set a passcode. You can set certain restrictions. Basically think of them as parental controls. You can run YouTube. You can run the App Store. You can't run YouTube. You can't run the App Store. But these entries are all entered by the user, and therefore they can be removed by the user very easily. If you set it so that it can't be removed by the user, you can actually install a password on some of these restrictions, not all of them. But in cases where you do install a password on some of them, you've also locked out other controls. So there may be, at a IT department level, you may want to go into individual devices issued in an enterprise and set these passwords, but then the user may not be able to change things that they might want to personalize that don't really have a bearing on your IT policy. So real quick, we'll just run through a demo here. Just a quick look again. Is that coming up? Excellent. Obviously, this is a jailbroken iPad. Otherwise, I wouldn't be able to do this. I was going to use a camera, and it just looked horrible. And this is actually kind of cool. Just real quick, in the iOS, most of you probably already know all this. But again, I'm going to show you some differences in a minute. The general tab over here on the left, you can see all the various things you can change. And I shouldn't drag that quickly. So here's how I was talking about restrictions. You can set things so you can, for example, disable Safari, you can disable YouTube, you can disable installing apps, which not only disables installing things through the App Store, it also disables installing through over-the-air profiles. Some other things, like there's a nice one there that came in, I think about 4.2, allowing changes to accounts, so you could actually lock out accounts. So you could say, okay, here's your email account, and you're done, and then lock it so you couldn't add new accounts later. And then there's the parental controls that I mentioned. Where's the passcode? Very simple passcode. You can turn it on. You can set it so that it's required as soon as you tap the little sleep button or lock button. And it can either be a simple password, which is a 4-digit number, or a complicated password, which is alphanumeric and whatever. But there's no further restrictions on what it can do. An interesting feature in this screen also is the picture frame mode, which when the iPad is locked, you have access to photographs from the photo album. And this can disable that mode because it's kind of interesting because if you happen to have sensitive data stored in your photo album, somebody gets hold of your locked iPad, they just start the slideshow and just wait, and sooner or later this sensitive picture of your super secret prototype thing might flop by. So something to think about if you've got these in that kind of environment. And then finally there's the erase data, which can either be off or turn it on, and it will erase the data after 10 failed attempts to unlock the device. And then finally, I wanted to show the VPN real quick, which not a lot for the VPN, unfortunately. There's L2TP and PPTP, just basic simple stuff. But these are all the kinds of configurations that you can set up as a user directly on the device. So we talked about that. Did I get both those? Yep. Okay. So that's how you can configure them from a device. But anytime you're sitting with a device, manually putting these things in, you're prone to error. You can make mistakes just from reading off a script, doing it wrong, missing a step, maybe doing things in the wrong order, though I'm not sure that really matters too much on this system. So Apple came up with a method to create pre-built profiles that you can then directly install. And those are obviously good for management because you've got a standard profile, you just put it out there, you know that it's going to be exactly the same on every single device that's been configured with it. There's no question about making a mistake, about doing something wrong. It's all there. You can also lock these profiles with a passcode that's tied just to that profile. And it's done in such a way that it only locks the settings that are in that profile. It won't preclude the user from making their own personalizations. And then what happens is, between the user settings and the profile, multiple profiles, you can have several profiles being installed, the system will actually look for the most restrictive superset of settings. So if you've got the person has said, oh, I want a simple passcode, but there's a profile that's been installed by IT that says, no, it's got to be complicated, the most restrictive setting or the complex passcode will win. But you still have to kind of go about and get these installed in some way. So for that, they have the iPhone configuration utility, which is a free app that they've got for Windows and OS X. And you can use it to install configuration profiles, provisioning profiles, certificates, etc. You install them all directly through USB. So now you just simply plug the iPad into a laptop, hit a button, transfer the profile, it's been configured. But the most important thing about iPCU is there's additional controls that are available to the IT administrator that you can't get on the device as the user. And I'll show you those real quick. So we talked about passcode. And here you can see where allow the passcode and allow simple value. Those are pretty much what was on the, well, that's so strange. The iPad screen is black, but it's still coming through VNC. So anyway, you can have the simple value there, but you can also say, make it alphanumeric. You can set a minimum length, so let's go for DoD spec. Let's say 15 characters. Let's say you've got to have at least 2 complex, and it can't be more than 90 days. Auto lock after 2 minutes of inactivity, and you can't use any of the last 10 passwords. So people are going to really hate you for this. And the other nice thing is you can change that failed attempts setting, where after so many invalid attempts at unlocking a device, it'll wipe the device completely. The default available to the user is 10 attempts. With this, you can set it to as low as 4, which means that you can DOS somebody just by going boom, 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 and it's closed out. Or you can set it for as high as 16. Now, after you get to about 5 or 6 missed attempts, it starts putting in a delay. So after, I think it's the 5th, you have to wait a minute. After the 6th, you have to wait 5 minutes, then 15 minutes, then an hour between attempts. And that even survives power cycles. So if you've been in there and you completely fat-fingered it, now you're in an hour-long wait, you got to turn even if you turn it completely off, turn it back on, you're still where you were before. So yeah, if you set that to 16, it's going to take like 4 or 5 hours for somebody to finally get to where your device gets wiped. So a lot more configuration capabilities for IT there. Restrictions. Similar to what we saw before in terms of disabling certain applications. There's disabling the App Store. You can also disable the camera or just FaceTime if you like. So they can use the camera to take pictures, but they can't do video conferencing. You can turn off a lot of different things. You can also force encrypted backups, which is for normal users is a setting that would happen when you connect it to your iTunes and backup. You can say, yes, I want to encrypt the backup. You give it a password. This allows you to set at a policy level for all the devices. Passwords have to be, or backups have to be encrypted. And again, you see some of these other things. For Safari, they give you some nice extra things. You can turn off pop-ups. You can set some cookie policies for only from visited sites or never at all or always. And then finally, for the last thing I wanted to show you was on VPN. Remember, there was only 3 different VPN types available to the end user. Going through IPCU, you've also got Cisco AnyConnect and a few different SSL VPNs that are available to configure. So if your enterprise is using any of those things, you can configure them for your users through IPCU and push out the profile, even though you might at first glance look at a device and say, oh, it doesn't work with us. Well, it might through this. So that's how that all works. Of course, the problem with building these profiles and hooking them up with USB and transferring them on is you still got to, oh, wait, sorry, did that. I have these slides in case my link didn't work. You still have to go around with a cart to all the devices, hook them up, do stuff. So Apple actually has a way that you can configure the profile, save the profile out to a file, and actually put it on a web server, and you just set the correct content type. And then all they need to do is go to a link, tap it in Safari, it'll download the profile, prompt them, and install it for you. There's also a much more secure way to do that that actually uses the Simple Certificate Enrollment Protocol, SCEP, to establish a secure exchange and actually create a unique certificate for the device, and everything goes back and forth. That's not very easy to implement. I started doing that, and I just got scared away. Apple actually suggests in their documentation to use Microsoft or Cisco SCEP servers. The problem with all this is that you still need the user's cooperation. They still need to get the email from IT and say, oh, go to this page in Safari on your iPad and tap this and it'll install the profile. You still need them to initiate the configuration. So that's why they created the mobile device management system. Basically, that's the over-the-air installation of profiles married with the push notifications that Apple has for sending messages directly to the device. Using this, you can just push a profile out to the device directly. The user doesn't have to be involved at all. But there is a downside, is that the user can still remove themselves from MDM. So even though you can force the profile on there and tell them by policy, not by technically enforced, but just by policy that, yes, you have to have MDM on your device or you can't get any of our stuff. Well, they can delete it if they want. I'm not sure if I said this later. When you do delete the MDM profile, it deletes also anything that was configured through MDM. So if you're enrolled your device in MDM on a corporate server, and they push out profiles that, for example, get you access to the corporate VPN, access to corporate email, and the user says, I'm done with this stuff, I don't like playing this game, and they delete the MDM profile, it'll also delete all those other things. So it's kind of a carrot and stick approach. You got to have the MDM to get the corporate services. And what MDM gives you is the ability to push out those profiles, the same configuration profiles as what IPCU generates. So all those extra features that you saw before, they're all available through MDM. but there's also some additional management and control features that we'll talk about. As I mentioned at the top of the talk, there's several commercial vendors out there that sell MDM services for iOS, and many of these go well beyond iOS. They support BlackBerry, they support Android, they support Windows Mobile, some of them support desktops, and a lot of these that we've looked at actually go well beyond just simply managing profiles and stuff for devices and go way into full-out asset management. You know, here's a desktop, it's running this OS, it's a Dell, it's got this serial number, it was bought on this date, it's in this office, and you can get very complicated systems. Also, it's now part of Lion Server, which is nice because that's only $50 and it makes it a lot easier to play with. But you still need a push notification certificate, and I'll go into the details there on the next slide. That's what you need to actually send the messages through the push notification service to the device so it can then talk to the MDM server. Previously, you could only get those through the developer program, so even if you bought one of these commercial products, you still had to go register with Apple as a developer just so you could get that cert. And they're now available through Lion Server, and I presume that there's going to be some method to do that for the commercial products, third-party products as well. So how does it work? I feel like I'm flying. At first, you've got to obviously enroll the device in MDM. And when you do that, it pulls a profile, a configuration profile, just like you create with IPCU, pulls that down into the device, installs it, and that hooks up all the little links that tells the device how to talk to the MDM server. Once that's done, whenever you want to control a device, whenever you want to query it or send something to it, the device doesn't have an outstanding connection with the server, but it does have a long-standing connection with Apple for the push notification. So what happens is the MDM server sends a notification to Apple, Apple passes it down to the device says, oh, MDM wants to talk to me. So it then makes a connection back to the MDM server, and then the MDM server gives it whatever commands it's got queued up for it. So to talk about the push protocol, this was actually the first thing we started looking into, and it's kind of interesting the way that they've got it. The device, you know, when it powers up, finds an internet, says, okay, I'm connected, I can do things. It makes a connection out to Apple, and it's using TLS, and it's using certificate validation at both ends. So the client makes sure that it's getting a proper cert from Apple, but Apple has to make sure that it's getting a proper cert from the client, and the certificate that it's looking for at the client is actually a cert unique to that device that's installed on the device by iTunes when you activate it. So you've actually got an Apple-issued, Apple-signed certificate unique to the iOS device that's installed on it, and that's used to help establish that APNS connection. Once it's all connected, any application that wants to communicate or receive notifications through the push service will then connect to the push service and say, hey, I want to use the service, and it'll give a unique token. That app will then give that token back to its service provider, like Twitter or an MDM server or whatever. And then again, that connection just stays open long-term, and notifications flow down from Apple. So here's what the push notification payload looks like. It's a very short message. The payload has to be 256 bytes or less. And the payload is sent in JSON format. And you can see down at the bottom there, we've got a breakdown of what it all looks like. The device token is what I was describing earlier. That's what's sent to the device by Apple for each application. So when Twitter wants to send something to you, they address it with that device token, and that's how it gets back down to your device. And you see the payload here has a top-level dictionary, the APS, with keys underneath it. And in this example, I just say, alert, you have mail. But there can be lots of different keys in there. There can be badge counts, which will change the little number sitting on top of the icon. It can be sounds that it'll play. It can be lots of different things in there. For MDM, it's almost exactly the same, except instead of having that top-level APS dictionary, it's just got a single string value called MDM, and in there is a token. In this case, it looks like a big UUID, random UUID. And that token comes from the device when it's enrolled. It's called the push magic token. And so together, the push magic token, provided when the device enrolls, the device token, which Apple gives it to do the MDM connection, and then the identification on the certificate. It's actually the subject/user ID field. I can't remember the exact X509 field name, but it's It's actually a field within the certificate. Those three things together are what authenticate the message. If somehow a push message comes to the device that doesn't have all three of those things that match, the MDM daemon will just ignore it. So how does the device enroll? Again, you go into the IPCU and you can create an enrollment profile, or with the commercial MDM products, it does all that sort of magically for you. But I'll show you real quick what that looks like. The mobile device profile, management profile here has, it's got a field for the server URL, and that's just the address of where the MDM server is, like probably just mdm.bigcorp.com/server. The check-in URL can be the same as the server URL, or it can be different, and that's actually the path that's used by the device when it enrolls. It can even be on a totally different server if you like. What they have here is the topic. That's what I was saying before about the subject ID, the user ID on the push notification certificate that you get from Apple. And then there's an identity, a cryptographic identity that you can install. You put it in the credentials tab down here. You can install a cert that's unique to the device, and you install it that way. Or you can use SCEP to have a certificate negotiated at enrollment time. And there's a signed messages button here, which I'll mention later on. And then finally, you can give rights, give capabilities to the MDM server on the device. You can say, yes, this thing can do all these queries, or it can only do profiles, or it can only change the password or wipe it or something like that. I think most people will probably have all those set to on. And so how do you install this enrollment profile? You can either use the USB connection from IPCU, or what I mentioned before, the over-the-air connection, to just install it off of a web link. Or certainly in a full MDM service, you can have things where, some of them work where you just log in from a Safari page. They just give a URL out in email, and you type in your corporate credentials, and it downloads the profile and goes everything from there. So here's what happens during the enrollment process. And now we're going to start getting into the real details. The first thing that happens, well, the very first thing that happens there on the right-hand side is the profile gets installed on the device. As soon as that profile is accepted by the user, they hit the buttons and whatnot, it connects to the MDM server and authenticates, which all it really does is say, hi, here I am, here's my unique device ID, the UDID. And the server can then say, oh, yes, you're supposed to be part of my MDM group. We'll let you in. Or, no, I have no idea who you are. You're a third party trying to get our stuff, so go away. Once the authentication is accepted, then it sends a second message that's called token update message. And that sends all the important stuff to the server. So I mentioned the push notification tokens, the push magic, and stuff like that, but also sends the keys that are needed to unlock the device when you do a clear passcode command. Everything is sent over HTTP, or if you enable HTTPS. And it's just a simple put. In this case, remember we had the server URL and the check-in URL. In this case, my check-in URL is just /check-in. So there's a put to check-in, and the rest of it is just this XML document. It's a standard format that Apple uses everywhere called a property list format. And I've highlighted the key parts here in red. There's a message type, authenticate, the topic, which again was the name on the push certificate, and then the UDID, which I've hidden any strings like that through all these docs. So that's what gets sent up to the server to say, hey, I want to enroll. And the server can decline enrollment, or it can send back just a blank plist, just a blank property list file, and that's all you see right here. It's just a simple XML structure with a little empty dictionary tags in the middle there. And that's accepted by the device as a valid OK response. I'm sure there's probably an actual official response that's supposed to be sent, but this works too. So once it gets that valid response, then it goes back to check-in, again with another HTTP put, and it sends up the token update. And this is where everything starts to get real. It sends the push magic, which is that UUID string, that gets sent back through the APNS message, sends the token, which is the device token that was given to it by the APNS service, and then it sends, again, the topic, the certificate, push notification certificate, user ID. And then finally, that last long binary string, it's like a 2 kilobyte string, all binary, all base64 encoded. That contains a bunch of data. I really haven't dug into what it is, but how it basically seems to work is it actually provides a key to, I believe, an escrow bag of some form on the device. So with that key, you can unlock that, which then allows you access to all the keys on the device, and now you can clear the passcode. That will become important in a little bit. So what can you do with MDM? There's 14 different commands, and I kind of broke them down into 3 different chunks here. You can configure the device. So you can install and remove configuration profiles that have all those different payloads and stuff that you saw in IPCU. You can install and remove provisioning profiles. And those are special profiles you get as an enterprise developer to allow internally developed applications to be fielded on devices throughout your enterprise. It's basically the code signing, the Apple stamp that says, yes, you're allowed to run this app without going through the App Store. Then you've got status commands, things that query the device for. You can get device information like the MAC addresses and how much memory is on it, what applications are installed. Security info tells you whether passcodes are compliant with policy. Restrictions tells you what restrictions have been set, YouTube's been disabled, et cetera. So you get all those different status queries. And then finally, the control. You can remotely lock a device. Just send a command and the device closes up and locks. You can clear the passcode if the user's forgotten it, and you can also erase the device, completely wipes it. So here's how the commands work. First, as I said before, the device creates that long-standing connection back to the Apple server so push notifications can come through. So then whenever the server wants to talk to the device, it sends the push notification packet out to Apple, which then sends it down through the tunnel back to the device. The daemon on the device says, okay, hey, MDM wants to talk to me. So it makes the connection back to the device, gets whatever commands it's waiting for, goes off and does the commands, then it comes back and connects to the server again and pushes out the response to the server. So there's 4 different connections that are kind of happening all through there. When the client gets the ping through APNS and connects back to the server, first thing it sends back is just a simple, hey, I'm here message, and what this looks like is just a status idle. Again, it identifies itself through the UDID, and this basically just triggers the server, says, okay, he's got my connection, the UDID uniquely identifies the device, so now it can go back to his table, find out what commands are waiting for the device, and send it back to it. And here's what the commands look like. Again, everything's just plist. You can tell I'm starting to drop off the XML headers and footers. And this has a top-level key called command, which is a dictionary of subordinate data. And most of them don't have extra content other than the request type. In this case, the request is device lock. And then there at the bottom, you see the command UUID. It's just a random string that's sent to uniquely identify the command that's being issued. So because of the fact that the command goes to the device hangs up, does the command, then comes back with a response. There's no link, there's no connection between the command and the response. So this command UUID allows the server to associate what it hears back from the device with the command that it issued. Because otherwise you might get responses from command 5 or command 1 right after you've issued command 5 and get all confused. You can also, as I said, add some other parameters to that command dictionary. In this case, for the unlock, for a clear passcode, there's an additional key that's been added, which is the unlock token, and that data is just that same big base64 string that was provided during enrollment. You just stuff that aside, and when I clear the passcode, you just stick it back in the command and send it out. So responses from the server, pretty generic. Again, just a plain old plist. You've got the command UID there, which again associates the command with the response with the command, and then a simple status. And most of the time, it's just says status is acknowledged. If it's not acknowledged, then you've probably got an error message of some form coming back. And the error messages are reasonably complete. I don't have an example on here, I don't believe, but it provides a unique code and a domain for the, sort of like an error type. Provides a standardized English message and a localized message for what the error was. Here's a much more complicated device response. So this is sending the device info request to the device, and it sends back all these different things. And you can actually specify in the command, you can specify as parameters the things you're interested in hearing about. And in this case, I just specify every single thing, and I only get back those items that are pertinent to the device. So like there's no phone number on here. If this were a phone, there'd actually be a phone number field. And you can see there's Bluetooth Mac, Wi-Fi Mac, the model name, the firmware, etc. So at this point, we actually know enough to create our own server. And I'll demonstrate that here will I demonstrate that right away? It's built in 300 lines of Python. Though I cheated, I'd used WebPy to do some of the heavy lifting for actually establishing all the HTTP connections. Also, I'm using something called APNS wrapper.python, which is a simple little library that allows you to create and send off. It handles all the management functions between the server and the push notification server. And that itself depends on OpenSSL command line utilities. It's a very simple command and response console. You send a command, you look at the response. And you send another command, you look at the response. So it's definitely not a real world thing. It's just for testing. So let's see. It's very rough. I do implement all the commands, but I don't have all the responses proper. So if something comes back from the device and I don't necessarily handle the errors properly. And it only handles one device at a time. So the last device that gets enrolled, that's the one that you're controlling. So if you're playing with this in your office, experimenting, trying to figure out how it works, and your office mate is also experimenting with it, don't both do it at the same time because you might end up wiping his device and not know it. So no guarantees, but it's a good starting point for experimentation. So let's see here. All right, let's start up the server. You see that? Cool. And if I go to the device, which is not locked, it's going to be hard to show you a device lock if I don't have a passcode set. Don't anybody remember that passcode. It's very secure. All right, so I'm going to launch Safari, and I've already got the connected to my MDM console. I'm just going to type in the URL for my enrollment profile, and what this will do will download the configuration profile I created through IPCU to the device. So you see there's a MDM test coming in. Actually, I don't want to make that too big because you want to see what happens here. So down there in red, you see it says sending enrollment profile. And up there, you can see it's got manual MDM test. I'll click install. Warning, installing this profile will change the settings. The people here at this address can do things. Collect personal data, lists of apps, add, remove accounts. Yeah, they told me to do it, so I'm going to do this. And now I have to enter my passcode again. And done. So now it's enrolled. So now if I come over here, and this is the very, very simple interface. Let's look for device information. I click that, I'll hit send, and you can see down here on the bottom, sending push notification, and then it received the status idle response. And so now the server sends out the device information command, and boom, it received 1,411 bytes. That's the response. Here's what I asked for. And you can see, like I said, phone number. There's a lot of things in here that don't apply to this particular iPad. And if I come down here and hit refresh, I should now see the response. So there, it sent the message out to Apple. Apple sent it back down through Sprint, Clear, whoever they're called. Went into this thing. It then connected to the server. The server gave it the command. So all that kind of happened magically. So that's That's MDM. That's an MDM server now. And there's a bunch of different things you can do with this. Like I said, if you've got, we can look at restrictions here. And there's really no restrictions. It says, it's just an empty dictionary there. I can install a profile, and I'll hit send and watch the screen. Should see, did it go out? Acknowledged. Did that not do anything? Damn it. Let's try that again. There we go. I just removed YouTube and App Store and Safari. Just completely disappeared. And if I can come back here and we can list the profiles, you can see what's on the device. And that just gives you metadata. So you can see here, there's the MDM profile right here. Provides device management, etc. Then here's the profile that I just installed, configures device restrictions, and doesn't really give you a lot of details. It's basically just metadata, the name of the profile, when it was installed, etc. So if we come back up here again, because what I just installed was a restriction, so now this command should look different. There's the response came through. And now you can see that there's actually data in this restrictions response. So installing applications is false. Allowing Safari is false. Allowing YouTube is false. All those things disappeared. So, and then if I remove that profile, they should all come back. Ta-da! In a real environment, in a real server, obviously you would have pick what profiles you want to install, pick what profiles you want to remove. I just have a profile in a directory that just sends and removes that one profile. And then finally, we can lock the device. So, it's a do-it-yourself MDM server. I actually considered putting it in a QR code, but it was going to be like that big, and that's just too much. Where is my, there it is. What time we got? Still got a half hour, damn. So again, the MDM limitations. I mentioned this earlier. The user can remove the device from MDM control whenever they want to. It feels sort of backwards for a corporate device, especially if it's owned by the corporation, being used for corporate data. But Apple kind of made the decision that that's how they want it done. I guess maybe it's because they feel that these are personal devices and they still want some kind of personal level control over it. I don't know. Some things that MDM does not do, it doesn't address the commingling of data. So for example, if you've got lots of corporate data and lots of personal data on there, MDM doesn't do anything to partition the device to keep that data separate. I mentioned email accounts. You can't restrict the email accounts through MDM. So people can still create the corporate account, and then they can create the user account, and they can just drag mail from corporate to Yahoo. It can't detect a jailbreak. There was some talk about a year ago where there had been some APIs available within iOS that would detect whether or not the device was jailbroken, and then Apple removed those. So I don't know how they work because they're removed. There are certainly ways that you can detect a jailbreak looking for different signatures on the device, and a lot of the commercial MDM products have their own companion application that you'll install on the device that will do additional things like that, that'll look for jailbreaks, it'll handle additional data, things like that. So those things will frequently get installed through the MDM service at a corporate level, and that will handle detecting jailbreaks. And then you still need the push notification certificate. But again, with the Lion server now, that's a much lower barrier to entry. Some things that I was hoping it could do, but realized as we dug a little deeper that it just can't. It cannot change your passcode. It can erase it, but it can't actually change it to something new. And it was occurring to us that it would actually be useful to be able to do that. For example, if somebody's leaving the company, you can lock their device, and if you could set the passcode to something they don't know, then you guarantee they couldn't get into the device and do anything to it. Now, they could always hook it up to iTunes and wipe it, but at least it's, slows them down and maybe keeps them from accidentally doing something. You can't disable the microphone. which also, there's no voice recorder that comes standard on iPads, but there certainly is on iPhones. And if you walk into a meeting and just throw the iPad down on the table, I actually had an iPad 2 where I loaded a voice recorder, started it running, locked the screen, closed the cover, sat it on my desk, and it recorded a speakerphone conversation 2 cubicles and around a corner, which I was very impressed by. Some basic things that are available to the user but not available through MDM, the picture frame restriction that I mentioned before, that can only be changed at a user level, so you can't force that setting through corporate policy. And the account lockdown, where you can say they're not allowed to create additional email accounts or so on and so forth, that's also only available to the user. You can't set that through IPCU or through MDM. And then finally, the geolocation. Find My iPhone is a really cool service. You can call it up on the web and find out exactly where your iPhone, your iPad, whatever are. But that's not part of MDM. That's a different service, uses different systems, different protocols. So that's not available through MDM. I found a couple of interesting bugs while I was working with this. For example, when you're clearing the passcode, I mentioned that if you do the wrong passcode 3, 4, 5 times, after 5 or 6 times, it puts a delay in. So you might get a minute long, a 5-minute long, and oh shoot, now I'm locked out. I've got to wait 15 minutes before I can do anything. I finally remembered exactly what it is. I know I'm doing it wrong. You call up the help desk and say, hey, this is so-and-so. I'm the vice president of something you should be impressed by. Unlock my iPad. So they say, okay, sure, and clickety-click, and okay, I got the response. You should be good. No, it's still locked. Oh, well, you got to wait until the timeout clears. So you got to wait for 15 minutes to clear. That failure count doesn't get cleared when the passcode is cleared. So if you lock yourself out, have a 15-minute or hour-long timeout, call up, get them to clear the passcode, wait for the timeout to expire, swipe to unlock, now you're in the device. It pops up a little message, say, oh, you have to set a passcode. Oh, yeah, I'll do that now. I'll set it, I'll type it in. Okay, fine. Then you do stuff. You lock it, you go away, you come back, and you fat finger it because you changed the passcode in addition. When you set it, you changed the new passcode, so it's fresh or not fresh in your mind anymore. That number is still there. So if you were at an hour-long delay, you're still at an hour-long delay. Until you actually enter a valid passcode, that doesn't get cleared. That really surprised me, and I can imagine that would really piss some people off. Also, this was kind of an amusing one. What's wrong with that picture? There's nothing there. What that should look like, there's my, oh, damn it, that went all the way down, didn't it? I knew I was going to do that. What that should look like is this. And you see at the bottom, we've got the slide to unlock, and there's that little picture frame button and the time, date across the top. Where is that picture? There it is. What happens is if you have a simple passcode, just a 4-digit number, and you fat fingered a bunch of times, and so you call up the help desk and say, I got to get in, and that panel is still up. If that panel is up when the clear passcode command is sent, something weird happens. If after the clear passcode command is processed, you type in just a random 4-digit number, doesn't matter what it is because there's no passcode, it lets you in. But that's not exactly what you're going to do. That's kind of nonsensical. You're going to be like, well, I'm still here. It's not unlocked. I'm going to hit cancel. You hit cancel, you get this. And there's no way to enter it. You tap the button, you tap the other button, you shake it, you jiggle it, you do everything. You can't get that panel to come back up. You have to power cycle the device, turn it back on again, and then you get the panel up and you can then get in. So that was an interesting bug. But it didn't seem to happen with alphanumeric passcodes, only with the 4-digit numeric passcodes. And I haven't tested it on lots of different versions. So what are some security concerns? Well, first of all, I didn't seem to find any way to force authentication of commands. You remember when I was showing you the IPCU interface to create an enrollment profile, there's a little button there for signed messages. I can set that, but then because this is a really simple server I wrote, I never actually signed anything, and the device just accepts the commands, doesn't care. So there seems to be some kind of limitation or something where it just simply isn't doing a good job of authenticating the messages that come down. Also, the authentication at the HTTPS level, it appears to accept any certificate with a trusted root. So if you've got a cert that's actually, signed by somebody up higher, or if you've got a cert that's issued from a CA that the CA certificate has been installed on the device, then it will accept that cert for the MDM. It's not paying attention to the certificate that was issued when it enrolled in MDM and only talking to that server. It's just got to be a valid cert. And of course, with the man-in-the-middle attacks that's probably being talked about in one of these rooms next to us, especially with the certificate validation issue that just came out, man-in-the-middle attacks on that are pretty likely possible. And the configuration itself, the actual information stored on the device that describes how the MDM is configured, that's not protected on the file system. So if you can get onto the file system, even if the file system is locked, even though the device is locked, you can still get at that data. So what are some possible attacks? Getting into the Apple push notification system, trying to forge APNS messages is pretty difficult. I'm not sure how I could really get about that because of the way that because of all the validation that it does. So we need to man in the middle of the device. So if you can man in the middle it though, you can push out new profiles. And if you can push out a profile, you can do all kinds of great things. You can downgrade the security requirements, though it won't force the user to change to a cheap password because all of a sudden he's allowed to use a simple password. But you can at least downgrade other security requirements, or the next time they change the password, maybe they'll enter something simple and they won't realize it and it won't yell at them. I also figured there was a possibility for sort of a multi-step approach to install malware on the device. If you get a development license, and you can create device profile, then you can create a provisioning profile for a device. So if you're man in the middling, you know the UDID, you can create a provisioning profile for that device, then send a profile that includes that provisioning profile and a web clip. The web clip, when the user taps on it, will download your application. So now it's installed, the profile allows it to run. Now you've got an app that wasn't vetted by Apple, wasn't vetted by the user because you're man in the middling them, and now it's on their desktop. And if you couple this with social engineering, and you call them up, say, hey, this is so-and-so from the help desk. Oh, yeah. And, we've got this MDM. Yeah, I can't stand that. Now I can't watch my cat videos on YouTube. What do you need? So, well, we just installed something on your device. Oh, yeah, I see it. Can you tap that? Oh, sure. And they're going to trust them because they've just modified your device. So they're going to say, this must be IT. So, yeah, you combine that with social engineering, and that could be very interesting. Even more interesting, I think, is the possibility for denial of service. I mentioned that there's not a lot of authentication on the device, on the commands. When I was going through this and basically looking at the daemon on the device and running strings on it and saying, oh, that looks like a command, let's send that and see what happens. Oh, that looks like a command, let's send that. And I found the unlock command for clearing the passcode, and you got to send that big unlock token. I said, okay, well, oh, look, here's erase device. That's what we use to wipe the device. I figured I would have to send the unlock token. I was sure I would have to send the unlock token, but for fun, I sent the command without the unlock token, and it wiped the device. So you don't need any kind of authentication to the device to wipe it. You just need to be able to send a command through MDM that says erase device. So if you're a man in the middling, you can erase the device when it checks in. If an enterprise has a policy that, say, every morning the MDM server touches all the 1,000 iPads scattered all throughout its environment, and you've managed to man in the middle closer to their server. For example, if you've managed to break into their DNS and pointed mdm.bigcorp.com to you, you could erase every single one of their iPads first thing in the morning, as soon as they all check in, because there's no authentication on that command. So that could be kind of interesting. There are some good things. What do we got here? You can't install a profile on a locked device because it's changing it. I think possibly because it may actually need access to keys. I'm not 100% positive. So it might actually be not possible. Actually, it might be impossible to do it. It certainly doesn't let you. You can only read metadata about profiles. You can't read the details. So if there's a profile on there that configures corporate email, you can see this is the MDM, or the profile that configures the email, but you can't see the server name, you can't see the user ID, you can't see passwords, nothing like that. And you can't make a locked device resend an unlock token. So there are some good things that are there. Let me refresh, or go back a second here. You can't install a profile on a locked device, but you can install a profile when the device is unlocked. A couple weeks ago when I was working on this, working on what turned out to be the first draft of these slides, I accidentally discovered that if you reinstall the MDM enrollment profile on a device, it will re-enroll the device in the MDM, which will send a new unlock token. So it can't store the unlock token because it's actually a key. It gets created, it gets sent, and then it gets thrown away. The device doesn't have it anymore. But if you force it to re-enroll in MDM, it'll create a new token and give it to you. So this means that there's an evil mate attack that we can do. If you can get a device to talk to your server, and if you can get a copy of the MDM profile, you can reinstall that on the device and get a new unlock token. Now, the next time you get physical access to the device, you tell it to poll your server, send a clear passcode command. Now you've got access to everything, including all the stuff that's protected by that really long passcode that you can't brute force because it's too hard. You copy the device as fast as you can and you leave. So, dear God, don't do that. So first you have to man in the middle, and they're using standard man in the middle techniques. You can do Wi-Fi trickery, you can do forge SSL certs. Up until 4.3.5, you could use an iPhone device cert to sign your own cert and it would take it, which was actually really cool. Since you have physical access to the device, you're going to need that for the next steps anyway. Get onto the device, add entries to Etsy hosts. You might even be able to install your own certificate. I'm not positive about that. So some of this might actually become easier if you get onto the device. But how do you get onto the device? There's some kind of complicated approaches you can do where you can boot into the DFU, the device firmware update mode. And once you boot into that, you can get into a tethered mode where you can actually get access on the file system, get a remote shell on the device, read, modify, export, change, etc., stuff that's on the file system. So if you get into that mode, then you can look on the, now you got access to the device. It turns out that the data for MDM that's present in the configuration profile, in the configuration profiles folder, there's a file called mdm.plist, which has got information like the server URL, the push magic, et cetera. That's not enough to re-enroll in MDM. That doesn't actually duplicate what was sent out by the server. But there is a file that's apparently left in there that does duplicate this everything in the server, and it's just sitting in that directory. So you pull that file back out, put it on your server, now you've got a duplicate of the exact original file that was installed. But because we can't forge APNS, we can't push to it. There is a way to make the device pull. If I mentioned you can't install a profile when it's locked. If you try to install a profile when it's locked, the device sends back a response to the server. Instead of status idle or status acknowledged, it says status not now. It says, I can't do that right now. I'm busy. I'm locked. When that happens, the client sticks that aside and it just remembers, and it puts a little file there called MDM outstanding activities.plist, which is literally just a status idle message. It puts that in the folder, and as soon as you unlock it, it will say, hey, wait, I've got stuff that I still need to do, and it'll connect to the server. So we can touch that file. We can actually just create that file on the file system, and it will immediately pull. If it immediately pulls, it gets an install profile that says, wait, then it'll not do anything until you unlock the device. So normally, like I said, if you install a new MDM profile, it will normally fail. If you've got a device that's enrolled and you try to enroll it in a different profile, in a different server, it'll say device already managed by MDM. But if the profile does exactly match, it will re-enroll, and it will re-enroll silently. There will be no user notification at all. I actually, the first time I really tried to pull this down, I actually had a video running and sent the profile out, and it re-enrolled, didn't skip a beat. When it re-enrolls again, it sends all the token information, the device token, the push magic, and the unlock token. Can't do anything with the APNS tokens because we don't have the right push certificate, but the unlock token is what's nice. So yeah, again, once you do that, now you've got the clear passcode command. You set up your server to wait to send that. Next time you get access to the device, you get on with the DFU mode. You, again, touch that file, create the outstanding activities file. It connects, and server says clear passcode. The device says OK, and now you're in. But now there's no passcode. Now the user will know something's up because he'll come back from the hotel bar, tap his laptop and his iPad, and wait, why is this unlocked? Well, what you do is you lock it yourself. You take the token update that it sent to you, and you send that on to the real MDM server. So now the real MDM server, the actual corporate server, has the new unlock token, has the new push magic, so it can now talk to the device again. And then you set a bogus passcode on the device. And once that's set, the user will come back, he'll try to unlock it, it won't work, he'll try to unlock it, it don't work, he'll say, oh damn, I must have had too much brandy tonight, he calls up for help, they send the clear passcode command, it gets unlocked, nobody ever thinks of it ever again. So the basic scenario, very similar to the typical evil maid. Important target is at a conference, he leaves his iPad in the hotel room, you break in, set up, get onto the device, get the profile out, you create a little man-in-the-middle server, stick it on a notebook or something like that, you hide it under the bed or behind the AC vent or something like that. But it's set up such that that's going to be what it talks to. It's going to be the Wi-Fi it connects to, that's going to be the server it talks to. CEO comes back, he unlocks the device, as soon as he unlocks it, boom, you've got the token. And then he sits there and reads and he's clicking his email, locks it, drops it down, goes off to dinner. You break in again, force the poll, clear the password, duplicate the device, cover up your tracks, and get out. Is this crazy? Yeah, it's a little crazy. But for a really high value target, it's probably not unheard of. Some of these things are pretty difficult. Certainly the DFU tethered boot is not easy. Putting the server in the middle, not easy, but not really hard if you know what you're doing. The rest of the stuff is trivial. So, and the general logistics, I'm calling that moderate to difficult because you still have to get into the room. But I mean, certainly you can do that. So is it crazier than a regular evil maid? Maybe not by too much. What is crazy is trying to demonstrate it. So I'm actually going to sit because this is, okay. Whoop. Now I'm not going to do the DFU boot mode because I'm not that crazy to push my luck that much. But let's see here. The hell? All right. So this window is my existing server. Let's interrupt that. So it's no longer running. So MDM server is gone. Let's go into my evil maid. You can see there's no credentials. This server here, the evil maid server, has no information, doesn't know the push magic, doesn't know the device token, doesn't know anything about the device at all. So now if I connect into it, now again, in real life, this would be a tethered booth, DFU mode, crazy stuff, but this is much easier for a demo. Go to var mobile, library configuration profiles, and that file right there is what I need. So what I'm going to do now is scp root at 168.37.37 : copy var. I can't do escape completion when the shell's not running. All right, now if I cat that, you just see a whole bunch of stuff scrolls by. And the important part is right here. I'm going to grab that. Copy. And pull out the base64, or decode the base64. Now I've got test.mobileconfig, which is the profile that my server will install. And just to see, diff test.mobileconfig with server. How did I get out of? Now I'm really confused. I must have hit CD and didn't notice it. No difference. So the configuration profile extracted from that stub is exactly the same as the mobile config file, the configuration profile that I installed when I enrolled in MDM. But remember, in this window, I'm not me. I'm an attacker. So I've just got that profile. Now what I'll do is I'll come back here to the evil side, and I'll start up the server, and I was actually going to drag this over, because you should be able to see stuff come through here. I can't get any narrower. That's really dumb. All right, so I will SSH back into it. I will cd to var mobile configuration. I left a file here so it would be easier. MDM outstanding activities.plist. And when I hit enter, you'll see things come by over here. So do that. And now scheduling poll of MDM server, transaction completed, MDMD stopping. If I come back here to this side, I see, oh, I'm an idiot. I didn't set the right command. Set that to install profile. All right, let's do that again. Boom. It should pull. Install profile, not now. Okay, so because the device is locked, it's not going to install. So if I then come back to here so you can see the device, and because we don't have great resolution, you'll have to look at different things. So you'll see the server will say, hey, I'm issuing a token or getting a new connection. You'll see things go by here, and this will show you that the user doesn't see anything at all. So let's see if this works. Slide to unlock, type in my passcode, and does things. Scheduling poll, authenticate, blah, blah, blah. And over here, token update and device enrolled. So I now have credentials. I now actually have the token update, the push token, the unlock token. I have everything I need to attack this device. So now, let's say he locks it again, which of course you can't see. So now it's locked. Now I'll go back to my evil server, change it to clear passcode. So now the next time, oh, my server's not running. Boom. So now the clear passcode command is queued up. I wait until I have access to the room again. I go back in. We break onto the device with the DFU mode. I touch this file. It connects. And you see handling request type clear passcode. And there's actually something I wanted to show you. Where was it? Old pass equals secret. New pass equals null. It's this little bit here that makes me wonder if there isn't a capability to change the passcode. It's just not implemented yet. But that's speculation. The important part is it says passcode cleared. And if I come back here, tap the device, slide to unlock, and ta-da, I've now broken into the device. So that is the evil maid attack. And actually, it doesn't have to be an evil maid. It doesn't take a lot to turn this into an evil lackey attack. If you change hotel to office, change the maid to the frequently passed over deputy to the deputy of the assistant, and instead of a hotel bar, it's the office gym. I mean, the attacker could enter the office with a stack of papers, make off with his iPad, go back to his office, do all the magic stuff there, bring it back. Guy comes back up. You might actually hasten the attack by screwing up his desktop. You know, you unplug it or do something so the desktop doesn't work. He comes back from the gym. He's got to check his email. Well, shoot, my desktop isn't working. All right, I'll use the iPad, and he does stuff, and now you've got his token. And then a week later, you can just repeat the process and get on it, and you've cleared the passcode. Now, of course, in a corporate environment, you've also got other avenues of attack, like attacking his desktop and stuff like that. But still, I mean, it doesn't have to be a very complicated scenario in a hotel. It can certainly happen in a corporate environment or anywhere else that you have physical access to the iPad. So how can Apple fix this? They can fix it pretty easily. Unfortunately, we can't. There's nothing that we can do to configure the iPad differently or to configure our MDM server differently. But if they were to do a few different simple steps, if that stub file, I have no idea why that stub file is there. If they remove that so it's not present, I won't have access to the profile. I won't be able to silently re-enroll. If it has to be there for some reason, then obviously they should find some way to protect it so that when the passcode is locked, it's encrypted, I can't access it. That alone would be a big step. But it was occurring to me on the way over on the plane that if you're using SCEP to install the profile on the devices, then it's entirely possible that every single profile installed on every device will be identical because it won't have a unique device certificate. It'll get that certificate through SCEP from enrollment. So you might be able to DFU your own iPad, take the enrollment profile off that, and then get the others. But no, I think I'm confused for something. Anyway, if they protect that, that'll make a big difference. Better use of TLS if they actually were to remember the certificates that it sees. So when it enrolls, if it gets the cert for the server and says, okay, this is my MDM server, if that changes, I don't care if it's a valid cert signed by somebody I like, I'm still not going to accept it. Or if they actually do enforce some kind of authentication on the commands, if they actually have to sign the commands and the signatures don't match, again, not matching what you have on record, not simply checking up a cert chain. You've got to actually, I think, record what the correct cert is for the server. If they don't match, reject the command. There probably should be a user acknowledgement for that re-enrollment. The fact that it was completely silent boggled my mind. I mean, when I was doing this, it was literally an accident. I sent something and hit the wrong button, and all of a sudden I see things scroll by. I'm like, what the hell? And saw nothing on the screen. But the fact that your device sitting in your hand is silently telling somebody else how to get onto the device, I think the user should probably know that. So there's really no reason why that shouldn't at least pop up, hey, so-and-so wants to manage you. So that would help a lot. And then finally, it'd be nice if there was some additional authentication for the wipe command so that you can't do a massive denial of service on everybody's iPads. So at the beginning, I said the reason I was here is because people ask us how secure is it. So how secure is it? Well, notwithstanding the few things I just showed you, it's actually not bad. I mean, the protocol itself is sound. There's some limitations. There's some holes. But the issues that were found are reasonably easy to fix. And they're also not easy to exploit. I mean, it's not like this is something I can just simply point and shoot at, some random iPad in the second row or something like that and get control of them. You've really got to work to get at these vulnerabilities. But the protocol is pretty straightforward. It's now openly documented. There's a white paper, it should be on the conference CD, that describes all the protocol in great detail. I'll warn you right now, I'm quite verbose. But it's all there, and as well as both on the CD and as basically an appendix, a 3-page appendix of the paper, is the actual source code to the server I've been using. So you can use that as a starting point, play with it, look at the protocol yourself, see if there's other things you can work with. And hopefully this will be, people can work with this. Just a quick note about some of the docs I got for information. Apple's got some good stuff about a lot of detail about how their push notifications work. Very good document on over-the-air profile delivery, where they go into all that SCEP stuff that just drove me crazy. I told you I use the APNS library for Python. Everything else is on the conference site, and eventually we'll put it up on our corporate website as well. So again, don't forget the speaker surveys, and that's that. Any questions? Well, one in the back of you first. Yeah. How do you decrypt an encrypted configuration profile? I don't think I've tried. I think it's actually encrypted with the device certificate, because in the enrollment process you can establish a credential for that device, and I think it's encrypted with that. I tested this evil bait attack with a third-party commercial cert, or MDM server, so I actually installed and enrolled in a real server that had an encrypted cert, had encrypted communication, so I actually had to do SSL man in the middle, had all that stuff, and it still worked because I could get that stub. It didn't matter that it was encrypted. I still had the original encrypted stub, and I just replayed that whole thing back, and it got me in. But in the general question, how do you decrypt an encrypted profile, I haven't looked into that. I imagine it's just, it's all just SSL PKI. And in the front here. Mm-hmm. All right. The only part that goes through the third-party providers, it goes through Apple and then through your internet and so on and so forth. The only part that's going through that is the push notification. And that's just the UUID string saying, hey, they want a message. Apple's docs actually say, don't use the push notification service for anything critical, anything personal, anything secret. It's just an open channel, and it's just a ping. But then the server, once the client receives that push from Apple, then it establishes its own connection to the server. And that's the part that we can do better by making sure that you're using TLS, you're using good certs, et cetera, et cetera. Does that help? OK. Anything else? All right, thank you. Oh, yeah, follow up? I'm sorry, say that again? Can you trigger the re-enrollment and have it point to a different server? Okay. Yes. Yes, because when it sounds like you're asking if you're man in the middling and a push notification comes through and they talk to you instead of the real server, can you tell it anything you want? Absolutely, you can tell it whatever you want because there's no indication in the push message what the server wanted to do. So all the command happens when the client talks to the server and says, what do you need? And since it's talking to you instead, you can tell it whatever you want. Does that answer your question? Good. All right, thank you.